Okay, today I'm going to talk about the sampling distributions and the central limit theorem. Sampling distribution is the probability distribution of a sample statistic that is formed when a sample size n are repeatedly taken from the population. Sampling distribution of sample means is when the sample statistic is the sample mean, then the distribution is a sample. Every sample statistic has a sampling distribution. So what that says is that we're going to take a sampling of the population and we're going to use that to make a deduction about the population. And the other part is that they're saying that the sample mean is the same as the population mean. Next, we're going to go into where it shows that the mean of the sample equals the population mean. So sample means equals population mean. Then we have a standard deviation for this, which is the standard error of the mean, which is the standard deviation over the square root of n. Then if we want to transform the sample mean to a z-score, we do the sample mean minus the population mean over the standard error of the mean. And below you see what each letter stands for. Then we go into central limit theorem. Central limit theorem says that if n is greater than or equal to 30, that's drawn from any population with a mean and a standard deviation, then the sampling distribution of a sample means approximates a normal distribution. The greater the sample size, the better the approximation. So what they're saying is that we're going to make a deduction about the population mean from the sampling. To find the probability when giving a sample size, always when given a sample size, we're going to do normal CDF, lower limit, comma, upper limit, comma, the mean over the standard error of the mean, which is the standard deviation over the square root of n. Now, if you turn to page 341 and 340 in your book, and if you look at number 6, it's asking you to first describe the mean distribution, compute the mean and standard deviation of the distribution. Well, the mean is the same as the sample mean, which is 20, and the standard error is 3 over the square root of 36, which is the n size, and you get 1/2. On B, they tell you to find the z value corresponding to the sample mean equals 19. So you do 19 minus 20 divided by the half gives you -2. Then they ask you to find the probability of the mean distribution of less than 19. And this is where we use normal CDF, -1,000, 19, comma 20, comma the half that we got from A. You get 0.0228. Then if we look at 13A, where they're telling you that coal is carried, A says what's the probability that one car chosen at random will have less than 74.5 tons of coal. So in A, as you can see, they didn't give you a sample size, so that's why we use normal CDF, and we do it the old way, -1,000, 74.5, comma 75, comma 0.8. You get 0.2660. But then if you look at B, they give you a sample size of 20, and now they ask you to find the mean distribution for the sample, and this is why we are going to use the same thing that we did in A, but for the standard deviation, we're going to do 0.8 over the square root of 20. Then if you go to 8B, it tells you if the original X distribution is normal, we can say anything about the mean distribution of random size 16. Again, they're giving you a sample size, so this is why we're going to use the standard deviation over the square root of 16. Next, we're going to go into 12A. 12A says what's the value of the mean of each of the two mean distributions. So they just want you to tell you that the mean is the same as the population and the sample. Then we're going to go into 15. 15A says what's the probability of single text X is less than 40. Here they did not give you a sample, so it's the old way. On B, they give you a sample size and they give you a hint. They tell you to use the central limit theorem, and they tell you to do it over the square root of 2 where they gave you the sample size. So you just have to see the difference. One is they give you x is less than. On B, they give you the mean distribution is less than. Okay, so next we are going to go into, we're going to stop right there.